Okay, so we are starting Unit 5 today, but before we get into sort of the new information, I wanted us to review our chemical names and formulas from Unit 4, which is what we finished the semester with right before break. The reason we're taking the time to do this today and have you guys practice and review a little bit more on these is because the first part of Unit 5 is writing chemical equations. And basically what that means is you're going to be like translating. So you're going to be given either a sentence that has chemical names written in the sentence description, and you're going to have to translate those to the chemical formulas so that you can write the chemical equation. Or you might be given a chemical equation with the formulas, and you may be asked to go the opposite way and translate those formulas to their names and sort of put it in a sentence description. So, because that's the first part of Unit 5, if you are not confident in writing chemical names and formulas, it's going to be pretty difficult for you to do that. So, that's why we're taking today to sort of review and recap how to write all the different names of all different names and formulas of chemicals that we learned in Unit 4. So, the way that I set it up for today is I just did one page and it has all of the tutorial videos from Unit 4 that I had put up for you guys to look at before you took your Unit 4 test. And so if you are having trouble or you're not, maybe there's one, you're like, oh, I'm not so sure about the acids, or I'm not so sure about, the ionic ones that have the Roman numerals, or the ionic ones that have polyatomic ions, or whatever type of name and formula it is, then I would definitely encourage you to go to this page. And it has several videos. You can read each one of their titles to see which ones you want to look at. And if you need extra help when trying to figure out how to do these names and formulas, definitely look at those. Okay. If you are still, fairly confident, maybe you just need to kind of practice a little more, then maybe you don't necessarily need to watch those videos. But if you are struggling and having trouble, then definitely your first thing needs to be to go watch some of these videos because they are a good help. Okay. The second page here has these flow charts. And so when you click on it, there are two flow charts. One of them is for writing chemical names, and the other one is for writing chemical formulas. These two flow charts are what you're going to be using a lot today because they're to help you, they're to guide you, and kind of walk you through step by step the process of how to write chemical names and formulas. And the reason for that is because we learned different types. We learned ionic compounds, and then within ionic, sometimes they had Roman numerals, sometimes they had a polyatomic ion, which was slightly different. And then we had covalent compounds, and then we had acids. And then within acids, there were the binary acids that just had hydrogen and a nonmetal. And then there were the oxyacids, which had hydrogen and usually two other elements, some nonmetal and oxygen. Okay. So when you look at these flowcharts, and I already have them open in a tab, so I'm going to go ahead and show them to you. So this one is the one that you use if you're trying to write the name. So this would mean they give you a chemical formula and you are trying to figure out how to write the name of that compound. And so for this one, you start up here in the top in the center. This very first question says, is there a metal in the compound? And so how the flowchart works is you're going to answer each question yes or no, and you're going to follow the arrows to the next question until you get to sort of the end. You're going to end up at one of these boxes towards the bottom that is going to tell you how to write the name based on the type that you have categorized it as. And so there are all this left half over here, all of these are all ionic, okay? Because remember, we have some that have Roman numerals and some don't. Some have polyatomic ions and some don't. So there's like 4 different kind of subcategories here. Over here on the right side, you can see here's where how all my acids are, and it has the different types listed here. And then here are my covalent, my binary covalent, where it's just 2 nonmetals. And then there's this other section here that we haven't really talked about yet. These are going to come up on Wednesday when we start doing chemical reactions, because these are the 7 elements that exist in pairs naturally. So anytime they pop up in a chemical reaction, like if they say you have oxygen gas, it's never just O, it's always O2. Okay. And so we'll see more of that on Wednesday. The other flow chart is for writing the formula. So on this one, you start over here kind of on this top left corner where the star is, and you do the same thing. There's a question, you answer it yes or no, you follow the arrows and keep doing that until you get to kind of the end where it has the instructions for how do you write the formula for that compound, okay? And then on this one, it even has like the prefixes here for the covalent compounds if you need to know what prefixes the numbers are for covalent, okay? The other thing that you're probably going to be referring to a lot, probably for most of this semester, is your reference chart, which if you're on our Canvas page, over here on the left side, underneath home, we have home, announcements, modules. The fourth thing is your chemistry reference chart. So if you click on that, it's going to open up a page and it's going to make you open up an outside link. And so when you open that outside link, you're going to see this file, okay? The first page is a periodic table, and then it also has a lot of other information underneath. Like here again, here are the prefixes for the covalent compounds. Here are those diatomic elements that I just mentioned on that other flow chart. Here are all the most common transition metals with their two most common charges, so you know kind of what Roman numerals they might have. On the second page, over here on the left side, this is the list of polyatomic ions. You're going to be looking at this a lot, okay? Because you're going to have to be looking up either their name so you know their formula and their charge, or their formula so that you know how to write their name. We're also going to be using this thing right here called the activity series in this unit when we get to talking about our types of reactions, and we'll be predicting certain types of reactions. And so there's one type of reaction that we have to use this activity series for as well, okay? There's a lot of other information on this second page. Some of them we have already learned, some of them we have not, okay? So like here's the equation for density, okay? But a lot of these things we're going to get to throughout this semester, okay? So you definitely want this open because it will help you with the polyatomic ions, the prefixes, and it also has all your element names and symbols on it as well on the periodic table. So I have all three of those open in tabs so that I can kind of quickly refer to them. And then after you kind of look through your flowcharts, if you want to open them up in separate tabs, you can. You have sort of your practice assignment for today. And the practice assignment, it's a mixed bunch of chemical names and formulas. So it has ionic, it has covalent, and it has acids. So if you read the instructions, it says you're asked to do two things for each one. You're asked to identify if it's ionic, covalent, or acid. And then number two, then you're going to write either the name or the formula. So the way that it works, on the first page has 1 through 50. Those are all formulas. So that means on 1 through 50, you're going to tell me, number one, is it ionic, covalent, or acid? And number two, you're going to write out the name of the compound, okay? The reason that you are having to tell me if it's ionic, covalent, or acid is because you have to know which type it is in order to write the name correctly. Because if we look at the naming flow chart, you know, if I don't know if it has a metal or not, then I'm not going to be able to answer the questions. I'm not going to be able to get down to, oh, this is an acid, or oh, this is covalent, or, you know, all these are ionic. So if I don't know which type it is, then I'm not going to know which method to use to write the name. For the other page, which has 51 through 100, on those you're given names. And so on those, you would still, number one, tell me if it's ionic, covalent, or acid. But then the second part, you would be writing the formula of the compound, not the name, because you're given the name. So the way that you can do this is you can either, if you have access to a printer and you would prefer to print out the worksheet and complete it, you know, by hand on the printer paper, and then use the Adobe Scan to upload that scan of the worksheet, that's fine. Or if you don't want to print it, or if you don't have access to a printer, you could just do them on your own notebook paper. And then same thing, use the Adobe Scan app to scan and then upload that PDF for here to submit. So notice here, I put it kind of in a different color so it would sort of stand out. You only have to do evens or odds. So you are not doing all 100 problems. You are only doing 50. You're doing 25 names and 25 formulas, okay? Because I realize that that's a lot, so I'm not going to make you do 100. But the best way to get better at doing this is to practice it a lot. So you are going to do 50. You're going to do 25 names on the first page and 25 formulas on the second page, and that'll give you a good mixture of doing both directions and practicing all the different kinds. So I'm going to leave it up to you to choose evens or odds. And so evens meaning you would do like 2, 4, 6, 8, all the way up to 100. If you choose odds, then you'll do like 1, 3, 5, 7, all the way up to 99 would be your last one. Okay. If you are going to do it on your own notebook paper and you're not going to print out these 2 pages, then please make sure that you number your problems neatly and in order so that when I'm checking it, it's easy for me to check to see if something's right or wrong or give you feedback, okay? So, you know, if I was doing number 1, I'd write number 1, and then I would either write ionic, covalent, or acid. And then after that, then I would write the name of the compound, okay? So that's what you should be doing on each one. So what we're going to do now is we're going to do a few of them together. So I'm going to do a couple of the names. I'm going to do number 1 and number 14. I'm going to do kind of the 2 at the top. And then on the second page, I'm going to do 51 and 76. So we can see sort of how each page should look and what you should be doing. And then I'm also going to look at number 24 because somebody had specifically asked about that one because that one's a little tricky. So what I'm going to do now is I'm going to switch over to my iPad so that I can write them out and we can work them out together. But you guys, what I want you guys to do is I want you guys to have open your reference chart, which is this, so that you can easily look up polyatomic ions. You can easily look up element names and symbols and prefixes. And then I also want you to have both of these flowcharts open. Okay, you can have the Canvas page open if you don't want to open them separately. Just have that Canvas page with these 2 flowcharts open because I'm going to switch over and I'm going to be on my iPad, so I'm not going to be able to share the screen with the flowchart with you. So you need to have your flowcharts open. You can open up your internet browser and open them up in Canvas. And then we are going to work through those problems that I mentioned together. Okay. So I'm going to stop sharing and then I'm going to switch over to the iPad as soon as I get it going. So take a few seconds, take a minute, open those things that I mentioned, the reference chart, which is on the left side of your Canvas menu, and then also open up your flow chart so that you have them to refer to as we go through here. Because again, the only way to get better at this is to practice it and to use those things. Use the flow charts, use the reference chart, because using them, the more you use them, the more you're going to get used to them and the easier it's going to be for you to do things. Okay. All right. So number 1 on here is NO2. So if I'm looking at my flow charts, okay, on this one, I'm trying to name. So I need to use the one that says the naming compounds flow chart. And the very first question on that one in the top in the center, it says, is there a metal in the compound? So looking at this formula right here, NO2, is there a metal in that compound? What do you guys think? Yes or no? Of the elements in here, are either of them a metal?
No.
No, they are not. So we have N, which is nitrogen, O, which is oxygen. And both of those, if you have your reference chart pulled up and you look at your periodic table, both of those are on the right of the stair-step line, which means they are both nonmetals. So neither of them is a metal. So I would say no to that first question, which means I would go to the right. And then my second question after that is the first element hydrogen? So looking at this formula, is the first element in this formula hydrogen? What do we think? Oops. So here's my first element. Is that hydrogen?
No.
No, N is nitrogen, right? So my second question for about is the first element hydrogen, I would say no. And then the box after that, it says count the different elements, okay? Because if there's only one element, that means that it's this special category of elements, and they're called diatomic molecules. And that just means that in nature, they don't exist as a single atom. They always exist in pairs of the same element, okay? But on ours, there's not just one element. There are two elements. There's nitrogen and there's oxygen. We have N and we have O. So we would go to the side that says two elements, which means that it is covalent and it's binary, meaning it's made up of two different elements. So that tells me, number one, this is covalent, okay, because of where we ended up on the flow chart. And then the second part, to write the name, that last box at the very bottom right corner, it gives me the directions. It says name the first element using prefixes except mono, because remember, if the first element is 1, we don't use the mono prefix on the first element. And then the second part is name the second element using the prefixes. And then we change the ending of the second element to IDE. So on this one, what's the name of my first element in this formula? What is N? What's the name of N?
Nitrogen.
Nitrogen. And I'm just going to write nitrogen. There's no prefix because if I look right here behind the N, there's no subscript. So that means it's an imaginary 1. And in the little rules in the box on our flow chart, it says that we don't use mono on the first element. So the first element's just nitrogen. Now, what about the second element? What is O? Anybody got their periodic table? What elements? Oh, somebody's saying something in the chat. Let me check. Yes, oxygen. Thank you, Sarima. So O is oxygen, and then our rules on our flow chart said that we need to use a prefix. So what prefix would we use for the number 2 right here that's on the oxygen? So it's on your reference chart if you can't remember, but if you remember, it is di, and then, oops, I forgot the I. So it is di, that's our prefix, and then our element's oxygen, but we changed the last bit of the name to IDE. So this one, number 1 is covalent, and then the name is nitrogen dioxide. So that's what you're doing on all of these, okay? I should have kind of 2 answers for each one, okay? The first one is what category is it? The second one is what is its name, or on the second half, its formula. So I'm gonna scroll down. We're gonna look at number 14, one of the even ones now. So on this one, I'm gonna still be using the naming flow chart because this is still on the first page. So I start with the same, I always start at the very top, start in the top center. So is there a metal in this compound?
No.
There is not, okay? If I look closely, there's 3 different elements here. I got hydrogen, which is H. I have chlorine, which is the Cl, and I have oxygen, the O. So there are 3 different elements, but none of them are a metal. They are all nonmetals. So that would be a no on that question. So then I get to the second question underneath the no. Is the first element hydrogen? What do you guys think? Yeah, right? This one, so if it has hydrogen, it's pretty obvious, right? It starts with an H right here. So on this time, though, we're going to say yes to that question instead of no. So if I say yes to that question, I go to the right, which means that it's an acid. So now I know the category. I know that it's an acid. That CI looks a little weird. Let me rewrite that. Okay, so I know that it's an acid. And then to actually write the name, now I'm going to follow the directions in the last box underneath acid on my flow chart. And so remember, there's kind of 3 categories for the acids. There is the binary acid, where it's just hydrogen and 1 element. Those are the ones that get to hydro on the for the prefix. And then there's the oxyacids. Those are the ones that have hydrogen with some polyatomic ion. And there's 2 different ways that that can go. You need to know the name of the polyatomic ion. So in this one, the polyatomic ion, I'm going to draw a box around it so we can see it if we're not sure. It's the ClO. Okay, it's poly because it's more than 1 atom. It's a chlorine and it's an oxygen. So I need to know the name. So I know that the name is going to end in acid. Like I can go ahead and write that, but I need to know like what's the first part of the name. So to know that, I have to know the name of this polyatomic ion because I need to know first off what's the main part of the name, but I also need to know its ending because according to our flowchart, if it ends in ATE, then the acid name is going to end one way, and if it ends in ITE, then the acid name is going to end a different way. So this is where your reference chart comes in, and you need to look on your second page of your reference chart, and on the left side, the list of the polyatomic ions, okay? And you're looking for CLO so that you can look up its name. Now, does anybody have theirs open? And can anybody tell me what CLO's name is? Let's see how many, if anybody's got theirs open. So we're looking for what is CLO. I'll give y'all a few seconds, see if anybody can find it quickly or not. All right, so I don't know if y'all just don't have it out or if it's just taking y'all a little longer to look it up, but you do need to get used to looking them up on your own because I'm not going to be here to do it all the time. But for right now, CLO, if you guys don't have your reference chart open to view, CLO is hypochlorite. Okay, hypochlorite. So that means the name of the acid is going to be hypochlor. Now, instead of ITE, if I look at my flow chart, it says if the polyatomic ion ends in ITE, then my acid ending is going to be OUS. So the ITE changes to OUS. And so this one would be hypochlorous acid. So again, here my answer is acid and then hypochlorous acid for the second part, for the actual name. All right, so I'm going to do one more. This is one that somebody in second period specifically asked for because the formula was a little confusing. And so first off, can anybody tell me what category this one's going to be just by looking at it without using the flow chart? What do we think? Yes, it is an acid because it starts with hydrogen, okay? So if you want to skip to that part of the flow chart, you can because there's no metal here. It's got hydrogen, carbon, and oxygen. Those are all nonmetals. The first element is hydrogen, so this is another acid, okay? Now, the part that's confusing for some people is the other part after the hydrogen. Okay, this is a polyatomic ion because it's got multiple atoms. Okay, when you look it up on the float on your reference chart, it's actually the very first polyatomic ion. It's called acetate. Okay, now there's two different ways acetate can be written. It can be written like this, where you have CH3COO, or we can put all the C's and H's and O's together and it can look like this, C2H3O2. Those are both acetate. So get used to recognizing both of them just in case you see one version or the other, okay? On your reference chart, it only has this one. It only has the CH3COO. So you might want to make a note somewhere that the C2H3O2 is the same thing, okay? So knowing that this is the name of that polyatomic ion, it's acetate. It ends in ATE. So then I would follow the rule underneath the acids for the ones with polyatomic ions that end in ATE, which means that this would be, I do ACET, and then I cut off the ATE, I change it to IC, and then add my word acid. So even though that one had kind of the hydrogens and carbons and oxygens in multiple places, I still do the process the same way, okay? Okay, so we're gonna do two of the names on the second page. So we're gonna do 51 and 76 because those are the two at the very top. So I'm doing one odd, one even. So on this one, you would want to switch over to your other flow chart, the one that's for writing chemical formulas. On this one, you don't start at the top center, you start on the top left where there's that little star by the box. That star is kind of like, hey, start here. And so the first question on this one is, does the name end in acid? So what do you guys think? Yes or no? Does this name end in the word acid? Oops. Go back down. Okay. It does end in the word acid. I mean, that's pretty obvious, right? It's going to have acid as the second word in the name, right? So if it ends in acid, which this one does, we say yes, so we go down. That means the formula is always going to start with hydrogen. So it's always going to be H with the +1. That's always going to be the first thing in the formula. So then if I go underneath that, it says, does the name start with the prefix hydro? So does this name start with the prefix hydro? Yes or no? What do you guys think?
Yes.
Yes, it does. Okay, it's pretty obvious. I can see hydro right here. I can underline it or highlight it, whatever you want to do. So I would say yes to that one. So I keep going down. And so then it says the formula, it's going to be this hydrogen ion, which is H with a +1, combined with some non-metal anion. And I would balance the charges just like I would an ionic compound. And they give me an example. They say if I have the name hydrochloric acid, then I would have H plus, and since it's an acid, and I would have Cl minus because the chlor part of that name tells me it has to be chlorine, okay? And the reason I know that Cl is just -1 is the group that it's in on the periodic table. So remember that there were 6 or 7 groups that you guys had to know the charges for, because that anything in that group or that family always has that charge due to the number of electrons that they gain or lose when they make bonds. And so chlorine is in group 17 or 7A, and they always gain 1 electron. So everything in group 17 or group 7A is always -1. So since that H and Cl, since they're both 1, +1 and -1, they cancel out and the formula is just HCl. Now on ours, we have hydro, and then after hydro, it's iode before the IC. So since it's hydro, we know it's going to be a nonmetal, and we're looking for the one that would start with IOD, which that would be iodine, which is a capital I on the periodic table. So on your periodic table, you would need to look what group or family is iodine in to know its charge. Well, if you look at your reference chart with your periodic table, it's in the same group as chlorine. Same with Cl, which is group 17 or 7A. So it also is just a 1. It's just a minus. Okay. So remember, anytime your charges are the same, they automatically cancel out. I don't need to do any math with like crisscrossing the charges or figuring out the number. If you have a 1 and a 1, they cancel out. Just write their symbols together. If you have a 2 and a 2, same thing, or a 3 and a 3, same thing. So on this one, since the charges are both 1, I only need 1 of each to make the formula balanced. And so the formula for this one would just be HI. So that's the formula. And then the first part where you had to tell me ionic, covalent, or acid, we kind of did that at the beginning because our first question was, does it have acid in the name? And we said yes. So that should tell me that it's an acid. So on this one, I would say acid, and then I would say HI. All right, the last one we're going to look at is 76. It's also at the top of that second page. This one, it's manganese 2-phosphate. So since we're trying to write the formula, we would still be using the formula flowchart. So starting on the left where the star is, does this name end in acid? Yes or no? Yes, Zarema, to your question. If the second element is there's no subscript, then yes, you use mono on the second one only. Okay, so no, there's no acid in this name, manganese 2-phosphate. Okay, there's no acid anywhere, so I'm going to go to the right. The second question says, does the name contain some prefixes? Like, does it have mono, di, tri, or any of those prefixes that are on our list of prefixes? So looking at manganese 2-phosphate, does it have any of those prefixes on our list? Sorimo says no, it does not. Okay, and that is correct. So if I keep going to the right, I say no, I go to the right again, and it says that means it's ionic, because if it doesn't have acid in the name and it doesn't have prefixes, then it has to be ionic. Okay. If it has acid in the name, then it's an acid. If it has prefixes in the name, then it's covalent. But if it doesn't have either of those, then kind of by default, it has to be ionic. Okay. So if I go down underneath that box, it says, does the name contain a polyatomic ion name at the end? So what do you guys think? Does this one, so it says at the end, so the end would be like the second word. So this phosphate, is that a polyatomic ion name? What do we think? Well, it actually is. So I got a couple people that said no. It is. The way I can tell that it is, anything that ends in ATE or ITE, that's automatically a polyatomic ion. The ones that are not going to be polyatomic ions, those are going to be the ones that end in IDE, because remember the elements from the periodic table, we always change their names to end in IDE. Okay. So if it ends in IDE, then most likely it's going to be just a non-metal from the periodic table. There are a couple exceptions that are on the polyatomic ion list. Like there is hydroxide, cyanide, and peroxide. Those are the only 3 polyatomic ions that don't end in ATE or ITE. All the rest of them, they're either ATE or ITE. So the clue here is that because it has phosphate, it ends in ATE, that tells me that yes, it does have a polyatomic ion in it. So I'm going to follow that arrow that kind of goes to the left and it goes down all the way to the bottom. And then the next question says, does the name contain Roman numerals in parentheses? So this name, manganese 2-phosphate, does it have Roman numerals in parentheses? It does. That's pretty obvious right here in the middle. Okay, it's got a 2 in parentheses. So if I say yes, then I'm going to go all the way to the one that's in the left bottom corner on the flow chart. And so then in order to do the formula, it says the metal has the charge of the Roman numeral. So that means my metal, it's going to be 2+ because this is a Roman numeral 2. So on my periodic table, I need to look up what's the symbol for manganese. Okay. Anybody remember? It was on your little practice assignment from last time. Anybody remember what manganese is? The symbol for manganese? If not, you can look at your reference chart with your periodic table. It is Mn, not to be confused with magnesium, which is Mg. Okay. People mess those up a lot. Okay. So manganese is Mn, and then I know it's +2 or 2+ because of the Roman numeral. If my ionic compound doesn't have a Roman numeral, then that's where I would need to look up what group the metal is in. If it's an alkali metal like sodium or potassium, those are all in group 1, so they're +1. Alkaline earth metals like calcium and barium and strontium, they're all in group 2, which is +2. The only one really in group 3 is aluminum. It's +3. Okay. So if you don't have a Roman numeral, then make sure that you look up the correct group for the charge of the metal. Now, for the other part, we know it's a polyatomic ion because it ends in this ATE. So that means that I would need to be looking on my reference chart on the second page, look on that list of polyatomic ions that's on the left side, and look for phosphate. And I need to know what is its formula and what is its charge, as I need both of those in order to correctly write the formula for this entire compound. So I'm going to go ahead and give this one to you so that we can save some time. But if you look up phosphate, the formula is PO4. So it's 1 phosphorus and 4 oxygen atoms bonded together. And the charge, it is 3-. Okay, it's a -3 charge. Yes, thank you, Sarima. So now that I have both of their formulas and their charges, now is where I need to balance the charges. This is what we do all the time with the ionic compounds. So there are 2 ways that we talked about how to do this before the break. I can do the crisscross method, which is kind of simple. The only problem with the crisscross method is that you have to reduce your number. So if I have, a 2 and a 4 for the charges and I crisscross them, I need to reduce them to be 1 and 2. okay? So the crisscross method is fine. It's simple and straightforward, but you have to remember to check at the end, do you need to reduce your subscripts down? Because can they be reduced to a lower whole number ratio? The other way that you can do it is you can do it kind of the math way that we talked about and that was in the tutorial videos. And that is simply looking at how do I balance the pluses and minuses out and make them all cancel out and equal 0. And so for that way, if I look, if you guys remember from before break, I told you there's kind of a trick when you have one charge that's 2 and the other charge that's 3. That what you want to do is you're looking to make them equal. Well, 2 and 3, because 3 is an odd number and 2 is even, the least common or the least multiple they have in common is 6. And so anytime you have a 2 and a 3 on the charges, you want to get to where you have +6 and -6, because that's the only way you're going to get them to cancel out. So if I need to have a total of +6 for the manganese, how many manganese do I need to get +6 if each one of them is +2? I need 4 more? We sure about that? Okay, add up all those +2s. Is that 6? So I got +2 here, plus this 2, that's 4, that's 6, that's 8, that's 10. Right now I got +10. That's way too many. I only need 6. So I remember I want my charge to be +6. I don't want 6 manganese. So I'm going to erase a couple of these because I need 3 total. So I need to add 2 more to them. Okay. So some of y'all are typing stuff in, and I don't know if you mean 3 more or if you mean 3 total. So, but it's 3 total because 3 times the +2, that gives me +6. Okay. If I multiply 3 by the charge of +2, that gives me a total charge of +6. Now for the phosphate is -3. So how many times, what would I multiply by, or how many phosphates would I need in order to get a total of -6? So what would I multiply -3 by to get -6? Yes, I would multiply by 2. That means that I need 2 phosphates. So I'm going to add a second one, because now if I add up these charges, those 2 -3s, that adds up to -6. So now I can say I have a +6 and a -6. So if I add that together, that equals 0. That's the whole point of writing the formulas for ionic compounds and using the charges to balance, is because all of my charges have to cancel out because they have to exchange the same number of electrons. Whatever electrons the metal loses, the nonmetal or the polyatomic ion has to gain them. So they have to be equal. Okay. So now that I know that I need 3 manganese, when I write the formula, I have Mn, and then I have 3 of them. So I have a 3 subscript because we wrote 3 manganese here. And then for the phosphate, we wrote 2 of them. So I need 2 phosphates. So if you read the directions on the flow chart, it says combine the metal with the polyatomic ion until neutralized. And then it says if more than 1 polyatomic ion is needed, put it in parentheses. So since we needed more than 1, we said we needed 2 of the phosphates. I'm going to have to put the phosphate in parentheses first, and then put my 2 outside of it. Okay. Now, this is where this one, you could have done the crisscross. It probably would have been shorter. But I just don't want you guys to rely only on the crisscross, because that's where sometimes we get mixed up and we forget to reduce our subscripts down. On this one, there's no need to reduce because I have a 3 and a 2. I can't reduce those any more than that. Okay. But whichever method you use, whichever you're more comfortable with, the crisscross and reducing or doing the kind of math balancing out way, either way is fine as long as you are understanding correctly how to do the formulas. Okay. So we usually don't have, if metalloids show up, usually it's a covalent compound because they tend to, they don't really show up in compounds that much. You might see silicon, but most of the time they don't really show up, okay? Because carbon's a non-metal, tin and lead are metals. They're in group 4 or group 14. And then, so if silicon, if it's in an ionic compound, then it would have a +4 charge because it would act like the metal if it's paired up with a non-metal. But a lot of times, if it's paired up with a non-metal, a lot of times it will be a covalent compound because it usually acts like. Are you asking about a specific question? Because I'm trying to figure out why. Is there one on the actual? Oh, are you asking about like number 3? So on number 3, that's going to be, we consider the silicon, that metalloid, we consider it a non-metal. So that one would be covalent on number 3, and it would be silicon dioxide, which is what sand is made of, which is what makes glass, regular glass at least. So yeah, so typically if you have one of those metalloids, it'll most likely be a covalent compound because they typically behave more like non-metals in the compounds. Now, if they're paired up with a metal, then it's going to be ionic. Like if you have, I'm trying to see if I can find one that has silicon or another metalloid. I think that's the only one I see. Is that one you asked about? Yeah. But yeah, so if you see silicon, and that's a non-metal, it'll be acting like a covalent compound because it'll be acting like a non-metal. I see another one, 37's also got silicon too, and that's covalent. I can tell it's covalent just because of the subscripts. It's going to have prefixes for those numbers. All right, so I'm going to